Hello everyone. My name is Naki Boo, and I'm back with my second Redstone tutorial, computational Redstone tutorial. Um, Basically this one's gonna be about logic gates. Um, so yeah, there's 7 main logic gates, and I'll be building them or showing the fundamentals of how to build them, and showing their truth tables at the end of the video. Again, there's going to be links in the description to videos that better describe everything I'm saying. This is just like an overview so we can get along to further things in the future. Let's get into it. Now, as I said before, there's 7 main logic gates that you need to know. There are more than that, but there's more logic gates than that. But there's 7 main ones that you need to know. And that is going to be the OR, which we'll build now. Basically, the OR just takes 2 inputs, or 2 or more inputs, and if both of them are on, one or the other, or both of them are on, then the output is on. And if, both of them are off, so basically it's just if A or B is on, then the output's on. Simple as that. Then the second one is and this is like the OR gate, except that A and B have to be on for the output to be on. So how do we do that? I mean, you can already see I have torches in my hands. So basically, if you have 2 torches set up connected to the inputs, then no matter what, they're going to be, and a piece of redstone dust in the middle, then no matter what, that redstone dust is going to be powered. Unless both of the torches are powered off, meaning both of the inputs are powered on. Only then will the redstone dust in the middle turn off. So you can have a redstone dust inverting that signal, which is going to lead us into our next gate, which I probably should have gone over first, but you know what, we're chilling. The NOR gate. NOR gate, super simple. You have a block, you have input. An OR gate is basically going to be the opposite of whatever input you have. So you can get that just by throwing a torch on the back of the block, and there you go. So if it's your input 0, your output's 1, and if your input's 1, your output's 0. Simple as that. So, after that, we can move to our the knots of these things. So basically, every one of these has a NOT gate connected to can have a NOT gate connected to it, which creates a separate logic gate. With OR, we build our OR like normal, except on our output, we just slap a NOT gate on the back. And bam. And we build our AND gate like normal, except for this one, it's a little neat. So with this, we basically have to build a NOT gate into it to keep the, basically already have our NOT gate built here. But we have to build another. So we already have our NOT gate built in. So we basically just need to leave that out, and we'll already have a signal that has already been passed through its first NOT gate. So we get basically the inverted signal without even, having that second part on. So that's our first 5 logic gates. The last 2, or 1 specifically, is the XOR gate and the XNOR gate. It's my favorite because it's the one you use in a lot of binary adders. Because its logic gates basically line up perfectly And it's the one you're going to be building a lot of different versions of. So it's really important that you learn the fundamentals of it. Okay, so basically you start off with a OR gate. And with this OR gate, we're just basically, we're going to put our levers down, and then we're going to knot the signal once. And that's to help our AND gate, which we're going to build later. Then we're going to knot the signal again and pass it through an output. So basically, we have our OR gate and all its functions. And now to build the AND gate, we're basically just going to build it on top of our inputs. So in order to do that, we're going to just, put some blocks down to prevent, weird signal flow. We're going to put our piece of redstone dust, and then we're going to put our torch. So it ANDs the two torches together to turn the signal off when it's both inputs are on. And that's just it kind of has the mixed functionality of an OR gate and a NAND gate. Yeah, a NAND gate. Because when both inputs are on, the output is going to be off. And when one or the other is on, it's on. And when none of them are on, it's obviously going to be off. And then and so basically, just to add an OR gate, you don't even have to build a separate one. Honestly, you just go to the end of it and just throw a block down, throw a redstone torch to it, and you basically just knot the signal, because that's how NOT gates work. It just inverts the signal using a redstone torch most of the time. So yeah, that's pretty much all of our logic gates. There's a lot more out there, and there's a lot better explanations. And since the audio glitched, and I'm basically making this voiceover, which is probably going to be horrible and not even close to lined up, but it's just, I'll link one or two good videos on logic gate explanations, and have a picture of truth tables up at the very end. So yeah, thanks for watching. Bye.